So you're in the back. You're Fishman, right?
Yes.
Okay, gotcha. So let's see if this will let me do this. Probably not. All right. Oops. And you're, wait. You're Jonathan. Okay, gotcha. Everybody's here. Hooray. All right, cool. So, so today we're going to talk about meshes and static mesh pipeline in Unreal. So to start that off, we're just going to go ahead and fire up the engine. And we're going to talk a little bit about how meshes work in Unreal and in real time, right? So, the thing that's really important to understand about, that I keep yammering on and on about is like the idea of efficiency with everything that we do, right? So we're not gonna step all the way through the steps of rendering a single frame, but the amazing thing about how complex rendering a single frame, especially in a deferred rendering pipeline, is that we are going to be working all the way through these very intricate steps of taking our geometry, figuring out where it is, deciding whether or not we render it, deciding which pass it gets rendered in based on the material, rendering all the objects of the same type with that material in a pass, and there's all these things on and on and on that happen. And one of the other things that's important to understand is that frames, as they're kicked out, are rendered in an asynchronous way. So asynchronous just basically means that it's things don't all happen sort of at the same time, right? Because they can't. Because if we have to render this statue, we have to first figure out where it is in space. The CPU has to figure out all that out first before it passes it and hands it on to the GPU to actually render the triangles, right? So understanding that the CPU can be thinking about the first frame, and while it's crunched all the way through the third frame, the GPU is only then just finally rendering the frame. So all this stuff happens sort of in these kind of like gradiated tiered steps, and it's important to understand that. And one of the things that we're going to talk a little bit about today is not only that the CPU has to understand where everything is, right? It has to understand the positions of the models. Are they animating? Are they moving? Are there physics being applied to them? Is an AI driving that object and is going to have to manipulate it into a different place next frame because the AI is moving it? Input from the player. Will those objects be spawned or destroyed based on gameplay stuff that's happening? There's all kinds of different things that have to be sort of figured out as we're working through this stuff. So after the CPU knows where the things are based on all these very complex things that are happening in the game engine, then it's gonna make this huge list of assets that are going to need to be rendered, and then it's going to start culling those objects from the list based on whether or not they need to be rendered, right? Because there could be if you're in a game, there could be a million things going on back behind you that that the GPU doesn't need to render, right? And if it doesn't need to render, it shouldn't be holding those things in memory, because that is not efficient for a game engine. It's going to slow things down and make things grind to a crawl, right? So one of the most important things that at a very base level that's important to understand about geometry is that a lot of it just doesn't get drawn. Depending on what you're looking at, right, or where you are, right. So it's good to understand that this is a process that happens in steps, and if you've optimized your scene well, this is a process that happens that where you have to set some things up in order for these things to happen, right? So the most simple type of culling, and all culling means is we're deciding whether or not something is added to this list to be rendered, is distance culling, right? And this is one of those things that you see people actually complain a lot about in games. They're like, oh man, this game has so much pop-in, right? You'll hear people say that all the time. There's so much pop-in in this game. Like, I'm walking down through this immense, very rich environment, and off in the distance I can see a tree pop on or something like that, right? Or the foliage on the tree pop on or something like that. Distance culling is what's happening when that happens, right? And all that means is at a certain point when somebody has had to like take the quality level and like start tweaking it so that we're hitting our target frame rate, some engineer or tech artist has gone, well, does it really matter if the little tiny pebbles render from like a kilometer away? Probably not. It probably doesn't matter if the little tiny pebbles render from more than 20 meters away, right? So distance culling is what that is, right? So you can decide whether or not a thing draws based on its distance from the player or from the camera, right? So and there are settings inside of Unreal where you can set per object whether or not there's a threshold as far as like if an object draws based on distance, right? And that's a very simple way to call things out because it's a very simple calculation for the CPU to make. Frustum culling is the next most simple culling type. Does anybody know? Does hopefully everybody knows, but who knows what a frustum is? Everybody know frustum? It's one of these things you'll hear people talk about. Fancy word. All it means is it's the camera's field of view, right? So in Maya, when you have a camera in Maya, and you see that sort of like pyramidal thing coming out of the front of the camera, it's sort of like the aspect ratio of the frame. But basically, that's what you see when you look out of the camera. It's sort of that frustum. So if you want to think of it as sort of like the view of the camera or the player, that's what it is. And essentially, all frustum culling is just what it sounds like. If the objects are within that frustum, then they're gonna render, right? If they're not, if they're outside of your field of view, we don't need to render that stuff, right? And I'll show you how you can actually like visualize this in Unreal. It's pretty easy to show. In fact, while I'm blabbing, let me start this up. I'm gonna do third person this time because it's
There's a really cool GIF from Horizon Zero Dawn showing frustum culling.
Oh yeah.
I don't know if you've seen it, but
Yeah, no, there's a lot of cool and it's like people do those videos of like this is the crazy thing that games look like when they're actually running, and you see like a kind of like an external camera view of the player's view, like looking around, and things are just like popping on and off as they turn around. Yeah, it's amazing what game engines do, and so I'll show you guys that. You can't. There isn't a good. I don't think there is a good way in Unreal to actually visualize it happening in real time. But you can basically freeze the frustum / occlusion culling in place, which is kind of a cool, eye-opening thing to see. So section 2. Okay. So jumping onto that, we have pre-computed visibility. And pre-computed visibility is something sort of special. I don't know if all game engines do this, but it's something that Unreal does. And basically, all it is you generate a volume. Like when we jumped through the place node, there was one tab that was like volumes. One of the volume types that you can create is a pre-computed visibility volume. And all that means is you place down these sort of volumetric areas where you know that the player is going to be in your level or the camera or whatever. And essentially what it does is it sort of like voxelizes that volume, and based on the different cells in that volume, it basically does a pre-calculation where it drops the camera into each cell, and it spins it all the way around, like every conceivable angle, does a ray trace as it does that, and it goes, if you're basically here, these are all the things that you can see in the world. And so it essentially, and this is this thing we talked about last time, if you can pre-compute something, it's awesome if you can, because then all of that overhead of having to do those calculations in real time are gone, right? Because all it's doing is looking up data that already exists, as opposed to trying to like calculate data on the fly, right? So pre-computed visibility is something we can talk about as we move forward. It'll help with efficiency. The least efficient type of culling, which still in a lot of cases has to happen, you can offload a lot of that if you do that in a pre-computed way. But the least efficient way is occlusion culling, and all occlusion culling is basically saying, I'm going to turn off things that are behind other things because I can't see them when they're behind another thing, right? And that's what occlusion is, right? So, for example, in this room, if I was sitting here and my camera was looking out here, I as a human understand that there's like a computer sitting underneath that desk, right? But as far as like if this was a game engine and I didn't see that thing, why would I want to render that / hold that in memory, that object in memory, if I know I can't see it, right? So that's basically what occlusion culling is. It's turning things off that I know are kind of like behind other stuff, right? So I'm not going to run all the way through this, but just note that occlusion culling is the most expensive way to do it, and if you can do some sort of pre-computed culling, it's much lighter. So just to show you what that looks like, if we go into this scene and say I place the camera right here, right? There's a thing in Unreal where you can call up it's basically a console command, so you can type things in and tell the renderer to do like fancy stuff. The way you get to that is the tilde key. Does everybody know what the tilde key is? It's this guy up in the corner. So if you punch the tilde key, you'll see that this little command line prompt comes up. And when that comes up, I can type in this command that's called freeze rendering. So if I type in freeze rendering, how do I get that up? You just hit tilde, which is this little key over in the corner. Of course, they make it the weird key, right? It's like tilde. Everybody knows what tilde is. So if you type that command in, freeze rendering, and there's no space, no capitalization, you hit return, you'll see there will be a little prompt in the viewport that says rendering frozen. And so now if I go in here and I turn the viewport around, you'll be like, oh wow, what happened? What happened to the rest of my world? What's going on here? These are the objects that are actually being rendered from that view when I hit freeze rendering, right? So it's a good kind of like visualization of what all of those culling types are doing when we're doing that. So why do I tell you guys this? Like you're like, why do if this is something that Unreal maybe most of the stuff it sort of does automatically, why do we care, right? The reason why I bring it up is because of this default scene in Unreal, I feel, although I've argued with people on this, this is somewhat inefficient, like as far as like how this is built, right? If we were to take this ground plane, given how large this area is, and like carve this up into a couple different subdivided modular mesh pieces, you would have to hold much less. You'd be holding more pieces in memory, but you'd be holding smaller pieces of data in memory, I guess is what I would say. So if you can carve stuff up and make it modular, and that's sort of like where we're going to be headed for like the end of class, you can make stuff more efficient. Now, at the end of the day, this stuff is not very complex. They're like literally just like 6-faced cubes that are stretched out, right? But imagine that if it was some like crazy tessellated surface that had all kinds of like complex materials on it. If it had to still hold all that stuff, and they're all different or something like that. If it had to hold all that in memory as we were moving around in here, that's going to be tough for Unreal to choke down, right? So so the way you turn that off, if you're stuck in it and you want to turn it off, is you just type the command in again. So I'm going to say freeze rendering. And you'll see everything will pop back on. But just note, it's like even if like say like you're right here, and like the very corner of this mesh is just like barely poking onto the frame. It's gotta render this whole mesh if this corner is in there. It's not like Unreal doesn't like have some special optimization where it goes, oh, well, it's just that one triangle. I'm just going to render that one triangle. And probably a lot of pre-rendering stuff actually will do that. Like it'll go, oh, I'm just going to render that one triangle, not the whole thing. But for game engine stuff, it's heavy if you have to have big, huge pieces of mesh all living in memory at the same time. And it'll make stuff chug. I can't tell you how many times I've helped optimize something, and one of the things I go to right away is like, well, how big is like this ground plane that's in the scene, right? And if you can start carving stuff like that up, it's gonna help optimize stuff quite a bit. So so there's that. So does that sort of make sense to people? And it's just sort of leading into, hey, let's chop things up and make them modular, because I used to say this in level design when I taught it, but like if you build your project in Maya and you build it as one big mesh and you just export the whole thing as one mesh, you fail. That's like maybe one of my only like fail states for the project. If you don't build your project in modular pieces, like we've talked about for like the prompt for the project, if you don't have like a ceiling piece and a wall piece and a floor piece, and they replicate down, say like some, potentially some hallway or something like that, then you are not approaching building your project in the correct way, and you've missed out on the thing that I whine about every single class, right? So please don't do that. Cool. So so let's jump into actually getting some of our own stuff in here. And so as we do this, big warning. This is going to start off real simple, but we're going to move into higher and higher levels of complexity as we sort of move on. So so let's go ahead and start. Oh, before I start, just so you know, all of this stuff that I'm going to go over about static mesh pipeline lives in the Unreal documentation, and it's a great little guide about how to best sort of like build Geo for Unreal, and there's all kinds of information about exporting, how to best do collisions and all this stuff. And one of the things that we are going to talk about today is building collisions and building custom collision, right? So so I'm going to fire up Unreal, or not Unreal, Maya. We already have Unreal open. And the first thing we're going to talk about, although it's not going to be really important for us like building these simple things to export, but I like to talk about it right off the bat because it's important, is the grid. So later on we're going to build some like a simple like starting block out of a scene, but the default hold on, my wake up. The default Maya grid is minuscule, right? So let's go take a look at that, right? If we go into the grid settings in Maya, and we set this back to the default, right, and apply that, here's the default Maya grid, right? And it's like, I want to say it's like, it's like literally like 12 centimeters wide, right? So if you're building something real small, that's great. That's like less than a foot, right? Like 12 centimeters is very small. But we're building, especially for this class, we're going to be building an environment, right? So, I would suggest that you work at a larger scale. The other thing this is going to help us with is if we set up a grid snap in Maya that's relatively similar to what our grid snap in Unreal is going to be, it's going to be a whole heck of a lot easier to like translate stuff into Unreal from Maya, right? So I like going with about 1,000 unit wide grid. So we'll do 500 here. And then I do grid lines every 100 units and 10 subdivisions, which will give us a 10 centimeter grid size, right? So obviously this is really big. It's funny because like I have students that come in to help, and I load up their projects on my grid, and they're like, "Whoa, what happened to my object? It looks like it got real tiny," but it's just because my grid is large. So I suggest working this way. I'm not saying you have to do this, but for me, it helps me think about how large things are. To be completely honest, I am a person who grew up working with not the metric system. So although I'm trying to be a better metric system person, the metric system is still very alien. Not very alien. It's somewhat alien to me, right? These are meters, right? These are meter-sized grid marks, and there are certain things that are like easy to kind of like correlate out to for people who are not metric system people. But like if you think about a foot being about 30 some. Approximately 30 centimeters, you're on your way to sort of understanding how large meters are, right? So, and the important thing is that Unreal works in Unreal units, which are essentially centimeters. So if you're already working in centimeters and you're going to Unreal from Maya and you're working in centimeters, then everything should translate over correctly and should technically be accurate as far as its scale and size. So if you work that way, everything will be great. If you don't, if you do weird things and you scale them later, you're going to be sad because things may not sort of match up. So let's talk about making something real simple, right? So, and I know you're like, as I make this, you're gonna be like, but there already are cubes in Unreal, and I'm like, yes, there are, but we're gonna make a cube because it's real simple and easy to sort of like wrap your head around the export process. How many of you guys had level design last term? Designers. Okay, cool. So some of this will be repeat, right? But hopefully, like, obviously for level design, you guys were building stuff that was mainly for like a block out and not for like final assets, right? So there's going to be some stuff that's repeat, but some of this stuff is going to be helpful down the road. So I'm going to create this cube. I'm going to make it a meter large. And I'm going to initially just go ahead and duplicate this off because I know later on I'm going to create the collision for this, right? So in order to sort of like understand the difference between a collision mesh and a renderable mesh, I'm just going to go ahead and take my renderable mesh and I'm just going to give it a quick bevel here. Oops. What? Let's do 4. Yeah. So it's nice and roundy, right? So So we're gonna kick this out later on. We're gonna give it collision, but for starters, I just want to show you how getting this thing out goes, and like the settings that I think would be appropriate for getting something out. So I'm just gonna go ahead and delete history and freeze transformations on this, and then we're gonna go ahead and do a file export selection. Some of you may ask if you've done this before. You may have worked with the game exporter. Game exporter is okay. My thing with exporting meshes is I feel like the game exporter makes some decisions for me. I like making all my decisions on my own. So if you feel comfortable with the game exporter, that's cool. Just note that I will, if you ask me questions about the game exporter, I'll be like, just use the export selection. So there we go. So I'm going to do export selection, and we are going to be exporting as FBX. Always export as FBX. Can you import OBJs into Unreal? Yes, you can. What does anybody know the problem with exporting or importing OBJs into Unreal? Perhaps. No. No, that's a good point though. Like basically, FBX can give you a lot more data, right? Because OBJ is mainly just points and polygons, right? The main bad thing that's going to happen when you bring in an OBJ into Unreal is that OBJs don't understand their they can't actually that's not true. They do understand their up access, but they don't translate their up to access across. So if you export a OBJ into Unreal, it's just going to assume, because what is the up access in Unreal? Does anybody know the answer to that? I probably didn't go over that. One of the main differences between Unreal and Maya is that the up axis in Unreal is Z, right, as opposed to Y. And if you bring over an object that doesn't have any understanding of its up axis, it's going to be turned over on its side weird, right? So don't use OBJ. You could if you wanted, but you're going to end up importing your meshes and then turning them right side up. And nobody wants to do that every single time you drop a mesh into Unreal. So there is a whole lot of other niceties about FBX. Things like we can build a skeleton and rig them and animate them, and materials come across better. Vertex color comes across better. There's all kinds of other niceties to FBX, and we'll talk about that as we sort of wander through this. So as far as exporting a static mesh, what we're going to initially do is static meshes, and all that means is static meshes are meshes that aren't going to move, right? It's just like the word that we're using means, right? They're static, unmoving meshes. Later on, we're going to talk about skeletal meshes. Skeletal meshes are for meshes that are animated and that have joints and a hierarchy system and move and deform and stuff like that. So down the line, we'll be doing animated meshes, but for now, we're just going to do meshes that do not animate. So the settings that are important live under this file type specific options in the FBX export. And I know that if you go into Unreal's or Epic's guide and you look at their Maya export preferences, what they think is a good, and maybe they're right, but I've always had luck with having both smoothing groups and tangents and binormals on. Technically, Maya doesn't really do smoothing groups, as it were. It's mainly based around edge smoothing, hardening and smoothing, right? You guys has everybody done edge hardening and smoothing before? Probably, maybe. But this is really important because if you are doing, or if you're using meshes that rely on edge hardening and smoothing to make your normal maps that you're baking onto them look correct, if you don't have that data coming across to Unreal when you export, it's not going to, your normal maps that you bake are not going to look correct. And what Unreal will do when it imports, if it doesn't have tangent and binormal data and smoothing enabled, like if it isn't reading that data in, it's just going to make some guesses, and it's going to like go, it should probably be sort of like this, and it's going to do weird stuff. So I leave both of these things on, and I'm always happy with the results. So if you want to try out the settings that Epic recommends, try it out. Maybe it works the same way. The other thing that I leave on is this referenced assets content. This is just something that I've been told. It's sort of like superstitious that is a good thing to turn on. What I've heard is it helps with if you're bringing in meshes and models that have like multiple material slots on them and things like that. It helps with making that come across smoothly. There are things that it helps with as far as if you are, I don't do this, but if you are importing meshes that have materials that are applied that already have like files associated with them and stuff like that, like texture files and stuff, it helps with that export as well. So down the line, I'm going and disabling all the animation features. Later on, we'll go back and enable this when we export an animated mesh. But for now, I'm going to leave this off. And same thing with cameras and lights. Technically, I think you can import cameras from Maya into Unreal, but we're not going to do any of that. We're going to do all of our camera animation right inside of Unreal. I'm not going to export audio or for right now. Embedded media doesn't matter. I don't have any kind of textures hooked up to this stuff, but you can actually embed textures into an FBX file. I leave these two on, these connections, just as a just in case sort of thing. Include children input connections. Basically, it's for if, say, you didn't delete the history on your objects or your meshes, it'll make sure that history comes across with the objects. If you want to be real clean, it's a good idea to just like delete history on all your stuff if you don't need it before you send stuff across. But this will help try to translate some of that stuff if you do have input connections on your objects. So last but not least, these last things are super important, or some of them are. This all has to do with scale, units. I leave this automatic on, and what that does is it takes the units that are inside of, like set as the preference inside of Maya. So in this case, it's centimeters, and you can see it's grayed out. It takes the centimeters and translates them to centimeters. If you uncheck this, I guess there might be a way to tell FBX that you're working in feet and you're going to have it translated over. I haven't had a lot of luck with that in going to Unreal, mainly because as far as I understand, Unreal translates units. It just goes units are units, and if you tell me that feet are centimeters, I don't care. It'll just go, you tell me this is 5 feet long, guess what? It's 5 centimeters long now. So I would just say leave this on automatic and work in centimeters, you'll be happy. If you are taking Nate's class, is anybody in Nate's class? Yeah, you know the thing that Nate does. And a lot of the reason why Nate works in centimeters as meters, which is really kind of a mind melting thing, is I think he likes it because it's a holdover from when in ZBrush there were issues with importing really large objects into ZBrush, so it was easier to bring small objects into ZBrush and have them work appropriately with things like Dynamesh and stuff like that. I think all that stuff has been sorted. I think it's not as much of a problem anymore. But if you are working if you're in Nate's class and you're working centimeters to meters or as meters, just export from here with these default settings on, and then there's an option in the import into Unreal to scale it up by a factor when you bring the mesh in, and you just change that import scale to 100, and it'll pop it up to true size. So up access, like I said, is important. This is one of the translations that Unreal makes. So our up access is Y in Maya, right? And that's what we want it to translate it as. when it comes over into Unreal, it'll convert that Y into Z and stick Z up in there, right? These two UI options I leave on. This is mainly when I'm doing animation stuff, but I just always leave it on anyway. It generates like a error log if any of your export stuff fails or does weird things. You're not going to have any issues with this with static meshes, but when we get to skeletal mesh exports, when you're exporting like a rig with joints in it and stuff, there's some things that can mess up. And if stuff breaks, it's good to have Maya go, hey, by the way, this broke when it exported, so you can see that happening. The last thing that is very, very, very important, underline, exclamation point. As it stands, and this is a good thing to like stare at if you open up the Unreal documentation, and like it should be highlighted in bright flashing red. UE4 FB export pipeline uses FBX 2018. Using a different version may result in incompatibilities, i.e. stuff might break. So this is kind of like weird. I would say that it's super fine to use backwards compatible versions of FBX. So if you export it, I actually generally leave this at 2016, 2017. Older versions will work. It just like make sure you check this, because if you've opened Maya for the first time here at Gnomon and you're working on Maya here at Gnomon and you don't have preferences and things set up here, by default, what it's going to kick this over to, even though we're working in Maya 2018 here, or I am, it's going to default to the latest FBX export, which is 2019, which Unreal does not support yet. So make sure you at least pop this down to 2018, otherwise you might have problems. And I always give the warning of there were like a couple years back they updated the version of Maya and the version of FBX, and students started like working on their projects at the beginning of the term, and they started kicking out like 2018 FBX files, and Unreal didn't support that yet. And the scary thing about what Maya does when it looks at those files, or Unreal does when it looks at those files, is it doesn't check them and go, hey, this is incompatible, and throws it out. It like still tries to import it. It's like, let's give it a shot. And what happens is, or what happened then was, it started importing it. It imported it halfway in and crashed, and then it left a residual file there that was broken. And so not only did Unreal shut down and crash, but they tried to open up their project again, and then it would immediately crash as soon as the project opened. So be careful with that. Don't use 2019. That's the moral of the story. Okay? So what were we doing? We were exporting a cube, right? But all this stuff is important, and it's good to know, right? So I'm going to export this object. One thing also, I know this is lots of me blabbering on about saving files, right? But the other thing that we want to make sure we do, and I'm going to give us a break here in a second, is this is something that I like doing. So I'm going to save this out into my Unreal project folder. If you don't feel comfortable with that, or if you don't want to do it, you can save your FBXs wherever you want. I like saving them into my project folder, not in the content folder, but into a new folder that I create in the project folder. And I generally call this something like source art. And this is just like a little folder that I import things from. The nice thing about it being in the root of the project folder is Unreal always knows where that folder is, because it's in the root of the project folder, and it can just like go there, right? So if you're working on a project and you're always sourcing, like, say, your Z drive, some folder on your Z drive, or like some folder on your removable drive, or some folder on your computer's extra hard drive at home or something like that, it's gonna like map it to that drive, and then when I'm gonna show you this trick for like we can bring in something that's essentially a cube as a blocking mesh, update it and refine it, save back over the same FBX file, hit re-import, and it'll propagate into our world, right? So it's a good idea to do this if you're interested. I'll show you later on down, as we work forward, I'll show you why this is important. So I'm going to go in here and create a meshes folder. And I'm just going to call this, and this is just sort of good housekeeping. In Unreal, it's a good idea to like prefix stuff. It helps you find stuff. It helps you understand what what type of files these things are. I'm just going to call this SM for the prefix, and then I'm going to call it my cube. And then we'll go ahead and export it. So there, we finally exported something. So back in Unreal, I'm going to sort of mirror that. I'm going to go in here and create a new assets folder. You can call this whatever you want. You can call it like import demo files or something. I don't know. Assets. I just like making a top level folder because in the content folder, when there's like other stuff living up here, I like having sort of like my own little directory where all my stuff lives. That's just sort of like what I like. You can throw your files about however you wish. So here's meshes. I'm going to create a meshes folder. And the other thing that's nice about this is one of the things I like to do is color code everything. So if you right click on a folder, you can set the color of it. I'm going to set it to blue. And then you can see inside of here, also in this directory structure, it's all color coded. So that's just nicety. It also helps other people when they're looking at your stuff to help understand where everything is. So I'm going to go ahead and say import. We're going to go dig for that asset, which is in my source art folder, meshes, my cube. And if I go ahead and hit open, we're going to be given this dialog box for the FBX import. So for right now, I'm going to turn off auto-generate collision. We'll talk about that and what it does. By default, if you have auto-generate collision on, Unreal basically just sort of like makes a cube collision around the bounding box of your object. That can be fine. In this case, it's very fine, right? Because it's a cube. But I'm going to go ahead and walk you through how to create a custom collision for your object. There are a whole bunch of other options in here. We'll talk about this as far as some other options in here. But the only other thing I'm going to set in here is there's an option for whether or not you want Unreal to generate materials. I always set this to do not create material just because it makes a mess. I like to have, because what's going to happen is it's going to generate my mesh in my meshes folder, and then it's going to plop down a material, like a default material right next to it in that meshes folder. And I like to organize things into like my meshes and my materials and my textures and things like that. You don't have to do things that way. I like to do things that way. Some people are cool with having like their materials live right next to their geo assets and stuff like that. It's all sort of like pipeline workflow stuff. Now, what I would say is if you start working at a studio that say uses Unreal or maybe even doesn't, always make sure you're doing it the way that they're doing it, right? They'll have some sort of best practices for how they organize their scene files, right? But this is the way I do it. You don't have to do it the way I do it, but I'm just showing you my way. So I'm going to say import, and our cube appears, right? So here we go, static mesh cube. It's really super exciting. If I drag it out here, it will exist. And one of the things that's important to see is that because I did not generate a collision and we didn't create a custom collision, our player is going to be able to just wander right into the middle of that cube, right? So that's probably not what we want. There might be some certain circumstances where you don't want your mesh to have a collision. The other thing to look at is that our pivot point for this object is at the center, right? And you may think, well, that's because the pivot of our object is actually at the center of that cube, right? But what I could do to prove that is not the case, and we'll talk about what is actually going on here, is if I take this object and I push it over here, and maybe I even take the pivot point and and I'm gonna like move it off onto this corner, and you're like, well, the pivot will show up on this corner, right? If I go ahead and export this, and if I export it right into the same place, you'll start to see the utility of having that little export folder in there. If I go back to Unreal and I right click on here and I say re-import, you'll see that where it placed the pivot is actually at the origin of the world, and you can't really change that. That's just sort of how the functionality works. So if I take my cube now and I center the pivot, I'm just going to move it back to the origin. Oops. Sorry. There we go. So we'll move it back there, and then I'm going to go ahead and take this, and we're going to set this up with its own collision geo, right? So how does generating our own collision geo work? So in this case, we're just going to create a simple cube collision, right? And so that or box collision, I guess, is technically what it's called. So this is just going to, the box collision is going to use this geometry's bounding box to generate a collision for the mesh. So the way we tell it that this mesh receives this collision object is first you have to name your renderable mesh, right? So in this case it does have a name, but we're going to name it something custom just to show that you have to name it something. So I'm just going to call it my cube again. This is case sensitive. So if I typed my cube on this one and it wasn't capital C, it wouldn't recognize this. So make sure that you do the case sensitivity. So just to go back here and look at where all this information lives, if you go into the static mesh pipeline, there's this mesh prefix for collisions, right? And if you see the box collision, the naming of the box collision objects is as follows. Capital UBX underscore the name of the mesh underscore two numbers, right? So this is a little bit confusing because sometimes people get confused and they actually put the parentheses or the parenthetical stuff around it. That's actually just to like denote that's where the mesh name goes. So don't actually put the parentheses in, right? And also here with the numbers, you're actually going to put numbers in this place. Oops. So if I go in here, I'm going to select my collision shape, and then I'm going to say UBX. So this is telling it what type of collision it is, underscore, and then it's my cube, and don't put the brackets or parentheses around it. Underscore, and then I'm just going to call this 01. You can actually number it. I could number it like 99 or 56 or whatever I wanted. It just has to have a unique number. So just for ease of numbering, I'm just going to call it 01. Later on down the line, I'm going to show you guys how to generate multiple collision objects for a single piece of geo, which is useful, and that's why there is a number on it. So if I take this and I'm going to go ahead and snap it right back over the renderable mesh, it does have to align with it. That's important. I'm also going to go ahead and I'm going to set this down so that the origin is on the base here. So and then I'm going to move this up and export this. So as I export this, both of these should be selected. I'm going to do a file export selection and save it right over the top of this. And if we go back to Unreal, if I right click on here and I say re-import, it should re-import right over here, and I'm just going to drag and drop it out here again. You'll see that it should be sitting right on the ground because I put the pivot on the ground, and that's really nice, especially if you want to like set dress really fast. Placing the pivot at the base of something is a nice way to make sure that it's easy to like just snap things on top of other stuff. And then the other thing to note is that if I move my player character around, he now collides with the object. The other way you can check on this, like as far as checking on what your collision is like looking like, there's actually a way to preview it in the viewport, but probably the best way to check it is to go into the static mesh editor. And the way you go into the static mesh editor for a mesh is you just go ahead and double click on the object in the content browser, and the static mesh editor will open. There's a whole bunch of things that we're going to get into later about different aspects of these meshes that we're going to edit. But if you just want to see what your collision looks like, you're going to click on this little tab up here, click simple collision, and you'll see the collision mesh, right? Real easy. So that's sort of, we just imported our first mesh, right? So let's take a break. We'll come back. We'll do a couple more more complex meshes, and then we'll move over into hey, how would I start blocking out my environment for the final? And that's it. Yeah. How did I get it to go where? Oh, how do you move the pivot? Okay, it's okay. So yeah, we'll come back in I don't know, 15 minutes or so. So let's try to be back by 3. Yo.
So I was talking to my uncle who used to work at Naughty Dog, and they do the centimeters to meters thing there.
They do too, also.
Yeah. So.
I honestly what I've heard people say is that because I wish I had time to sit all the way through Nate's class. I never had a chance. I've sat in on it a couple times, but I've never heard his explanation for why he wants that.
I don't think he gave us an explanation.
What I have heard from people is that he does it because of working between ZBrush and Maya and the engine.
I just thought it would be interesting for you to know that.
Yeah, that's cool. Yeah. No, in fact, one thing I didn't mention is when I was at Sony, we were set up to one unit, which was set to centimeters by default in Maya, equals 1 foot, which was even pretty weird because it's not even the same, system.
Yeah, that's weird.
So I don't know. I think what happens is I think when productions original productions start up and companies start using tools, they just make arbitrary decisions about how they're going to work, and then that gets locked in stone.
Yeah, I can see that.
So it's fine, and if that's what helps Nate make sure that he's able to help you guys solve issues, that's cool. I don't think there's anything wrong with it. It's just sort of
it's a little confusing.
It's just it's a little confusing. The other thing I don't like is I think you mentioned last week, if you have to make something smaller than a meter, then you're working with decimal place values, right?
Yeah, well, he kind of explained that a little bit. I think he gave us a script that made the grid a lot smaller, and it wasn't that we weren't supposed to make things bigger than a meter, but not quite 2 meters, or smaller than that. It's just so that it's snappable. Yeah, so as long as something's not over 8 meters, or it's okay if it goes below, because it just means that it's going to be on the 512 max.
I see.
Yeah, so it kind of made sense.
That's cool.
Yeah, I didn't quite get that the first class, but okay.
Nice.
Yeah.
Thanks for the info. Yeah, and every place works a different way. So
Right. I just thought it was kind of cool because
it's sort of It's good to be adaptable.
Yeah.
In fact, if anything, the cool thing about working with Nate like that is like you learn to like accept working with somebody else's system, weird system.
Right, and that's what you're gonna do in the studio, so. It's good to know all the different ways.
Sure. Yeah. Okay.
Yeah, we don't have
This is a little over, so
Yes.
And me how did you hear about this? Let me hear your group.
Yeah, I need to see if he has
Oh, okay. Yeah, and I wasn't clear about this, maybe completely clear, but the place where the grid snap is gonna be is in the origin. So if you go ahead and snap this up to the origin and export it from here now, then it will go to the yeah, of course.
Have you ever had a hard drive crash and able to recover data?
No. Is your hard drive just completely
It's not on. It's not.
Like-
It's plugged in, but it's not showing up.
and all you did was unplug it while it was still like
Yeah, so it like caught on my chair and then it went out and then
Did it
it
fall
fell
out?
out. Yeah. So I don't know. I
um,
didn't have like graveyard stuff on there, so the last 2 quarters, so I was just saving everything in the quarter. So I have a lot of things on there that
no, that's bad. Because like I've heard horror stories about some people just like barely dropping those things, and they just they're literally just like, no, never cannot open again. So I don't. It might be if it is like a mechanical thing, then that's a bad sign.
I don't know, I think I did all technically, and then it's like they can use it for it.
Sure.
But it kind of sucks because I might have to pay money and they can't. I was gonna use that level for, I did a cross weapons class last quarter, and I had this little bag, and I was gonna put that bag in there, and take a nice picture, and it's that. I think I might have the bag saved on my Google Drive, but I don't have level now. Sorry. What is the paper?
If you guys can be back by 3, I think we started about 45-ish. Go.
So did you import a mesh? Okay. Select like this mesh and see the little magnifying glass thing? That'll take you to that mesh in the browser. If you double click on any static mesh, it'll bring up the mesh. Yeah, it's just a preview. It also allows you to change certain attributes or properties of how the meshes work. And there will be some things that will change down the line. Things like we can edit like level of detail and how they render.
I missed the command for how to like freeze the video.
Oh, you hit and this pops up and then you type in freeze rendering all in big no space. And then if you program, you can see stuff in the background. You turn off, and then if you do that again, it'll unfreeze that
State. It's kind of, it freezes into a state of only rendering things that were visible at that time.
I'm not gonna say it, so I'll show you this. So here's the cube, and it's just like fitting the cubes. But if you have like, and I think it'll go like this. If you have like these cubes, right? Like the use case is the same. So that means if you vote want to do is set this to a standard of text density.
Isn't that just dictated by the size of the object? That's what I really understand why.
It is, but you can adjust the UVs so that it fits, because we're doing a pixel density of 512 per
So
meter.
things smaller means not to go through space.
Exactly. Yeah.
That's what makes sense.
And so see, under the transform pixel density, you can set 512 as a pixel density, and then you have to set the size. So like, okay, how will this fit in a 2048 texture? And or so this is bigger than, yes, exactly.
So basically, you want to
That's-
that component, which you
Yeah, something like that. Let me see in Alaska, that seems, yeah.
Okay,
Yeah, he hasn't really talked about it.
so,
Yeah.
so let's go ahead and move on. So what we're going to talk about next is convex. So convexity with collision. So we have this handy dandy yes and no diagram, right? So convexity just means that the angles on the surface changes on the object are all going to be pointing outwards, right? So in this case, everything points out, points out, points out, points out, right? All the way around. On these shapes, things are going in, or there are interior shapes, right? So, so if you're going to create a collision shape that uses convex collision, you can't have any of this kind of stuff. If you try to build something that is like that, Unreal will just kick it out and be like, "Sorry, I can't make that shape, Dave." And then it won't kick it out. It'll actually like build a weird approximation of what it thinks it should be, and it looks bad. So we'll talk about your question. Your next question may be, well, what if I want to make an L-shaped thing, or I want to make a donut, right? How do we make that, right? And we'll get into that. And that moves into sort of creating something that has sort of like a complex collision. But just to start, we're just going to create a single convex collision. So you can see this shape is not a cube, right? But say we want the player to be able to like walk up to this thing and then like go up the ramp or something like that, right? That would be a case where we'd want to use convex collision. So just like the other one, I'm just going to go ahead and duplicate this off, and this is going to become the collision. I just like doing this because it helps people wrap their brains around the fact that this is this is the display mesh. This is the thing we're going to see in the scene, and then this is the thing that's going to be the collision, right? So I'm just going to call this something like platform, maybe without the caps. Doesn't matter. It just makes it easier for me to not make mistakes. And then we're going to call the collision shape UCX underscore platform underscore 01, right? And then I'm going to move this object back over. Oops. I'm going to move this object back over in place, and we'll go ahead and kick this out. So file, export selection, and let's call it SM underscore platform, and export it. And so we'll go back into Unreal and import that thing. Platform, open. We're going to make sure it is not auto-generate collision. This import option box remembers sort of like your last choices, so don't worry about having to update it every time. So if I drag and drop this out here, we can just go ahead and check it in the static mesh editor. All you have to do to get in there is double click on this. But if I go into the simple collision, you can see that it has built that collision to work that way. And if we go ahead and try it out, in fact, I'm going to make it bigger, maybe. And we go ahead and have our character jump up onto it. You can see that we are traveling up the side of it, right, as we would hope. And just to note, like, why do we care about making custom collision? It's because of stuff like that. Because if we just went ahead and told Maya auto-generate collision for this object, what it's going to do is something like this, right? So turn on simple collision. If I go ahead and blow this thing away, Maya's going to do something like this. It's going to go, hey, I'm going to build a bounding box around this object, and that's going to be our collision. So you're not going to collide correctly with that object, right? So just keep that in mind when you use auto collision. When you have that checkbox on, it's just going to build sort of a bounding box around your object, and that can be fine because like you might be importing things that are just sort of like cube shaped, and if you are, I don't expect you to create custom collision objects for things that are cubes, right? Please don't do that. But if you need to make something that has like a more specific shape, please don't have everything just be cubes. Although I would say you'd be surprised if you actually went into a game how many things just have collision objects that are just cubes. Because it's simpler, obviously, to just collide with a cube. So let's take this like one step, like a couple steps further, and then we'll talk about like blocking out our scene on the grid, right? So I'm going to go ahead and just duplicate this. Oops. Go ahead and duplicate this off. And then I'm going to go ahead and turn this into a column. So I'm just going to go ahead and create a cylinder. Right. A little bit of a cylinder here. We're going to go ahead. I'm just going to leave it at that many subdivisions. But one of the things I want to show is if we're going to go ahead and create the collision mesh for this object, one of the nice things about cylinders is, as you can see, or maybe not see, but I'll show you in a second, the collision for this cylinder is already, it's a convex collision, right? So, but one thing I would say is if you can try to keep these things simpler, like I'm going to drop this down to like 10 subdivisions as opposed to 20. The collision can be a lot simpler and still represent your object pretty well. So this will be the collision, this will be renderable, and then what I'm going to do here, actually I'm going to go ahead and separate this step off and move this in. And then we'll go ahead and make like a capital for this. Right. And I know this stuff is all kind of basic, but it helps to know how to do some of these things. Right. So there's that. And what I'm going to do, although there's one thing I kind of want to show you guys, like how the functionality of this works. What I would do with this column is I would just merge these poly meshes together into one object, because I know I'm just going to move this column around. You might want to like knock this column over and have the capital and the bottom piece like separate or whatever. But if I wanted to use this just as a single mesh, I'd probably just do a mesh combine, right, and merge it into one polygroup. But I just want to show you what happens if you import this into Unreal with them as separate polygroups, just so you know sort of the functionality. So if I do an export selection here, and I go in, and I'm going to call this SM column, and I go into Unreal and we import it. One of the options, and this is in this roll down here, so I'm just going to not generate collision. I'm going to open the roll down, and you'll see there's this option that says combine meshes. Now you can have Unreal combine these meshes into one mesh if you want, and that's what this option does. But if, just so you know what's happening if this ever happens to you, if you don't select this and you bring in an FBX that's composed of multiple meshes, this is what's going to happen. You're going to import it, and it's going to bring them in as separate meshes. Now, you may want this. You may or may not want this. This might be what you want, right? So you might want to be able to like create the base of your column and then like be able to have it like knocked over or something like that, you know, and you know, have the top. Oops. Have the top. Oh, it's up there. Have the top over here. And this is another problem, right? It's creating the pivot at the here. But maybe you want to do something cool like that, right? In your environment, right? But if you don't want to do that, or you know, and you could potentially also just model that outside in Maya if you wanted, and you wanted it to be connected together, you can either, and I'm going to delete this. Delete. You could either do this and say import column. And say combine meshes, and in this case, it's going to bring it in as one mesh, right? Or what I would do, because if you're going to create custom collision for this, it's much easier this way. So I'm going to delete this. Back in Maya, what I would do is I would select all those objects and just do a mesh combine. And then I'm gonna just go ahead and delete history on here, and I'm going to call this column. And then each one of the collision meshes, I'm gonna name for that. So this will be UCX underscore column 01, right? I'm gonna go ahead and just to make my life easier, I'm just gonna copy this. I'm gonna select the next collision piece and just paste it into there. It'll automatically update the name to 2, and then I can duplicate this bottom piece and flip it over. And paste that into there, right? So this is the third collision mesh. And if I go ahead and move this stuff over, oops. I can pop this up into place. And then if we export this with all 3 of those, what we should get is you know, collision meshes that adhere to the shape of the geo. Does that make sense to everybody? Right? And so that's a compound collision shape, right? And so this is important, right? Especially like this might not be as important if you were like, you know, making just sort of a cinematic or something, right? But if you were making a first-person shooter game and somebody was peeking their head out around the side of this column and somebody shot here, and it would have been a headshot, and the bullet ricochets off the collision mesh that's sitting here, somebody's going to be real unhappy about your game. They're going to write some like mean Steam review. These developers don't know what they're doing, right? So there you go. So and you don't. If you make that mistake, you are a bad person. So so there you go. So let's go ahead and the last example. Well, I'm going to do 2 more examples as quick as I can. One of them is a sphere, and you might think of a sphere like you're not going to do spheres very often. But one of the things I like to show, as far as like how this geometry is sometimes generated, is I'm going to go ahead and bump this up. And increase the size. Maybe not that big. So with something like a sphere, there is a custom collision for spheres that is a spherical collision, right? And it's just USP instead of UBX or UCX. There's actually also technically now a collision capsule collider that you can generate from FBX. But one of the things I want to show is that not in all cases, but basically in most of these cases, the way that it's generating these objects is via is the bounding box of the collision geo. So if I look at this, this is my my renderable sphere, right? It's nice and heavy. So if I call this, I'm just going to call it sphere, and then I go ahead and what is he doing? I'm making a cube, right? So if I make a cube that's roughly the size of the bounding box of that sphere, I'm gonna make it a little touch larger because I had an issue last class where I was like, I made it a touch smaller and it just sat inside of it, like slightly inside, and you couldn't see it. I'm gonna call this USP underscore sphere underscore 01. And if I go ahead and select all this, export file, export selection, SM sphere, you'll see that when we bring it into Unreal, you'll see that if we turn on collision, there's this light green spherical collision that gets generated, and my collision geo was a cube, right? And the only reason why that worked is because for this specific collider, it just looks at the bounding box of that object, and then it generates this. It's basically like a mathematical representation of a spherical collision shape. So just to show that it does work, if I take this sphere out here and I put it up in the air and I turn on simulate physics and I hit play, it'll fall down and I can push it around and play soccer with it, right? So so there's spherical collision, and then the last thing I want to show, and this will kind of like translate over to like, say if you have a scene that has like arches in it, if you wanted to do something that has interior shapes or like an L-shaped wall or something like that, how do we do that? We just make multiple pieces. So the thing that I like to show off is like making a torus or like a donut shape. I like to call it a donut. The donut, it's a 3D thing. So I'm gonna make this, let's say 200, 75, bigger, and then I'm gonna bump up the this, so this is much larger, like say I don't know, 40. So just so we have a nice high-res renderable mesh, right? And then we duplicate this off as usual, and I'm going to go back to this one that has the history, and I'm just going to bump this down to something like 8, just so we have a real simple collision approximation, right? And this is another good thing to see with this is just that when you create convex collision shapes, they don't actually have to be watertight. So if I go ahead and select this loop on here, and then I delete the rest of this, you'll see that I have this section of the donut, as it were, and this can be a collision shape even though it doesn't have like the ends filled, like they don't have polygons on it. It just sort of looks at the volume of that collision shape. So so if I go ahead and I call this one donut, and then I call this one UCX donut 01. I can go ahead and duplicate this around. And I'm just going to, do duplicate special. You'll see that I now have donut UCX donut 0 through 8, and I can move this guy over into here. And you can see that the collision, like the way the collision lines up isn't super perfect, but it kind of doesn't matter, just to show you, like you can sort of be a little bit sloppy with this, and as long as the collision sort of looks like it's working, it's fine. So if I export this and I say SM donut, you can go ahead and import that. And what we should expect is not only should I be able to like, ooh, wait, that didn't work. Why didn't it work? Haha, troubleshooting. Did I spell something weird? Donut. I spelled,
You didn't grab it all.
I didn't select it all? Maybe I didn't. It looks correct. Anyway, let's try it again. Export. Maybe I didn't select the whole thing. Donut. Export selection. Yes. Re-import. And let's look at it in here. Yeah, so now it's working. And I should expect in here to be able to run into the outside of my donut, but also be able to jump on top of it and go inside of it, right? Or the big payoff here is I can make my donut dynamic, and then I can have it rain donuts from the sky, giant donuts, right? That's really the big payoff here. If you can't have fun with your donuts, what are you doing with your life? Right. And even stuff like this will work, right? So if we like stick these guys together, as long as that collision isn't intersecting, you know, I can go in here and simulate this, and it'll fall down, and those guys all knock each other around, which is pretty cool. So there's that. Oops. So there we go. Okay, so anyway, enough fun with donuts. Oh, and I'm trapped forever. No. Okay, so the last thing we're going to do is, in the last half hour here, is I'm going to pull up sort of a concept. So, but before I do that, you guys can realize, you guys can kind of see how, like, if you just chop this thing in half, then you'd have an arch, right? And that's one of the other things that's kind of like a little bit difficult to create as far as collision for architecture and things like that, right? So, so it's the same idea. If you're going to make an arch, you're going to build out sort of like subsections and pieces of stuff, right? So, so the next thing to do is, hey, let's go ahead and make sure that you know, you guys can start blocking out your concepts for your final project, right? So, I'm going to go ahead and save this this whole scene file. Save scene as. I'm going to go ahead and save it right into that source art folder. So if you want to save like a Maya project into this folder, or like a whole Maya project into this folder, you can. I'm just going to go ahead and make a folder in here for my Maya scenes. So I can call it Maya. And we'll just call this demo collision shapes. So this is just me saving this out so I can start a new scene. And in my, where is it? In my instructor folder, I got, in week 2 here, I've got this concept. It's not really a concept, it's a photo, right? So we're going to talk about like, you know, walking through this, right? So I'm going to block out a couple shapes for it, right? But so here's sort of the breakdown for that, right? And we'll go ahead and build out maybe at least the wall and this floor panel and maybe the roof, right? So just so we have at least 3 objects to stick in here, and we can sort of talk about how to start building a block out for our scene. Because I know a lot of you guys are taking environment for games right now, and you're like, this is old hat. I've already made my block out. I'm cool. But for other people, this is all new stuff. So I know it's kind of a mixed bag in here of people. So I'm going to start with the wall. I'm just going to go ahead and make a cube. And I'm going to keep this real simple. I'm going to try to keep this to sort of like shapes that are, you know, just representational enough to this object. And also we're going to kind of like try to make it really obvious that my whole workflow with save it into that source art folder and then update and manipulate and make these files more, or the objects more, like refine them more as meshes is a good workflow, because you can start with really simple things that are almost like all cubes, and then you can work your way up to things that are finalized meshes, and you can leave that blocking stuff in your scene, and as long as you're just hitting, hey, re-import this file, all you're doing is sitting there and re-importing and having the new stuff appear where the old stuff was, which is like, if you don't do that, you're like wasting a lot of your life like rebuilding stuff. So I'm going to say, let's just look at this. So, a lot of people, like the question, a lot of people are like, well, how big are these things, right? So in a case like, and with architecture, my thing always is look at the stuff that has a human scale, right? And I worked with somebody who was difficult teaching this when I was on a job once, because like what is the thing that has human scale in this concept? The railings, exactly, right? And we all know railings are, they approximately come up to our waist, right? They're about maybe 3 feet tall, right? So if we consider that our railings, this is how big a person is, maybe 2 meters is right around here. I know people are not 2 meters, but they're a little bit under, right? This is going to be like person height. Maybe my wall, and you can sort of fudge it. Like things don't have to be super accurate unless you're building something that is like has to be super like architecturally accurate and correct. A lot of times in game stuff, things are actually exaggeratedly large. Like if you don't believe me, go play a game right now. You'll find that every door feels like it's wide enough for like at least two people to like walk through side by side, right? And the reason for that is simple. It's about functionality, right? And this is something I don't think I yammered on about. Art for games is about functionality, right? Stuff has to work. Whereas for other things, it just has to look pretty, right? And for architectural things, there's kind of like a dual thing, right? It has to look pretty, and it has to be like perfectly accurate, right? So depending on what you're working towards, it depends on what we're gonna do. So, but I'm just gonna call this 3 meters just because it's easy for me to do that, right? So we'll grab this cube. I'm gonna say that the height is 300, just because it's simple. And I like making my walls it's probably a little bit large, but making walls about a foot deep is easy. So I'm going to do that. I'm going to make the width. I guess technically this is wrong because it's not really the depth of the wall, but we're going to make it the width. I'm going to make it 30, right? And then I'm going to make our length. I'm just going to make this wall. I'm just going to guess that this wall is about twice as long as it is tall, which is maybe probably not accurate, but it's close enough. So I'm going to say that it's 600 units. It's not 6,000. 600 units wide. Now, with this wall, we've got a wall now, right? But what I would say is before you're going to go ahead and say, I'm going to take this into Unreal and start building my world, right? What I would say is go ahead and pick a pivot point that makes sense, right? So, do we just want to leave the pivot point at the center of this object and drop it to the bottom? Maybe. For things like walls, I find that it's more useful to have a pivot at one of the corners or maybe at the center at the end of the wall. Hey, there's good old Joseph. Joseph is at Respawn now. He's working on the Star Wars game. He's one of my old students. I'm just going to hold down DV, and I'm going to snap it to here, and then I'm going to snap this to the origin, right? And why are we snapping it to the origin?
Because that's where Unreal reads it.
That's where Unreal's going to put the pivot, exactly, right? So it doesn't matter if I put the pivot here, if it's over here. Like if I put the pivot here and I think that the pivot's going to show up here, it's not going to show up there. It's going to show up at wherever the origin is. So we got to take our mesh and move it to the origin. And that kind of becomes annoying because like if I now want to create a ceiling piece off of the top of here, or like that catwalk piece, I may want to put that pivot somewhere else, but then when I export it, I'm gonna have to take the object and move it to the origin so that when it exports, it goes out with that pivot, right? So let's go ahead and take this, let's go ahead and take this wall out. So we'll go ahead
Worried
and,
about collision right now?
you know what, hey, how you doing?
Doing good
Are you gonna be around for a little bit?
today?
Yeah.
A little bit.
Are you just wandering around?
I was trying to get a new ID just to steal more substance licenses, but I can't.
That sucks.
Yeah. So Victoria's.
Aren't they paying you enough?
What?
Are they paying you enough?
Oh, yeah.
I'm just giving you shit. I'm just giving you shit. Cool. Well, if you're around, I get off in a half hour. I would like to talk to you.
Yeah, sure.
All right. Cool. All right. So, let's go ahead and we're going to save this out. I'm going to call it just static mesh wall, right? And you could, if you're going to have a whole bunch of different wall sections, maybe it's wall section window or something like that, because eventually we're going to throw a window into this. I'm just going to call it static mesh wall for now, or maybe wall 01 or something like that. So there's that. It's a good question about the collision. With something this simple, this is something where I'd say, hey, it's fine to just go ahead and let Unreal generate a box collision for this. Now, later on, if we did cut a window in this, maybe we would want it to create a hole to be able to like knock that window out or something like that. But for now, I'm just going to leave it a cube. So I'm going to export that and go back into here and import it, and we'll just so I can show you. Here's what it makes. So if we turn on auto generate collision with this wall piece, we pop this open. It's just going to look like that, right? This is going to build a simple box collision around this shape. So there's our simple wall. So I'm going to go ahead and create a new level because we can start blocking this out now. And let's go ahead and build a couple more things before we start constructing, right? So I'm going to go ahead and duplicate this, and we'll make the little floor panel, or like the floor catwalk thing. Because if you look here, there's sort of like these like walkways that have these openings down below. So this is going to be just kind of like if we're just doing blocking to start, it's just going to basically be a cube, right? And it's fine to just start with cubes and then refine from there. Because a lot of times it's good to just get something in here. And I'm going to build this so this sort of like is watertight sort of over the edge here. And maybe I'm going to make this a little bit less wide. So it's almost like maybe just like about 2. So it's 30 centimeters in plus 2 meters or something. So it's about a 2 meter wide walkway, which maybe is big enough. But the nice thing is if we import this stuff and we try it out, it's easy for us to test it and make sure that it works okay, right? And just building cubes to start is good. I'm going to then duplicate this up. The roof section is a little bit more complex, right? Because it's like a dome. It's like an archway, right? So for this one, we're definitely going to need to create our own custom collision. Oops. So I'm just going to cut into that. And then I'm going to go ahead and grab this face, and we're going to sort of decide maybe this comes out a little bit. Let's just bring it out here to let's bring it out to 500. I mean, we can always fix this later, but I feel good about that. So I mean, we'd probably come out to 600. But let's just try it for now. Because the nice thing about blocking is it's all about like testing stuff out first, like low commitment on the art level, right? We're just making blocking meshes, and you know, we get to test them, and then if things don't work out, we can always fix them later. So I'm going to bring this up because we have sort of our arch here, and then I'm just going to go ahead and like cut into here, and just sort of build this arch way out, right? And we can make this a lot more pretty later, but this is a good starting point, right? So if I want to bring this floor and ceiling out with the pivot point, again, it's just making sure that before we export this, I'm going to pop it up here, you know, because it's okay. Like a lot of times people's question is it okay to sort of like model and test out what I'm building, you know, and not just build everything at the origin? Of course, right? Because otherwise, how are you going to look at this thing and sort of like make decisions, right? So it's okay to build stuff together, but just make sure when you pop stuff out, it's going to come out as in the correct position. And there are actually scripts where you can just select an object, it'll pop it to the and you could probably make this script yourself. It'll pop it to the origin and then do an export. So this is going to be this, and I just almost did it wrong. So I'm going to select this and move it to the origin and export it. File, export selection, SM ceiling 01. Now, this we're going to want to build a collision for, but for right now, let's just get it in there and make sure the blocking for it feels good. We could essentially, maybe we should build it. So let's call this ceiling. And we will go ahead and I'm going to go ahead and duplicate this off a couple times. And just a real quick like trick, like because I know this has like a couple, I'm just going to delete these out. And this is just going to be, this will just kind of work for this, but you know, it's easy to do sort of stuff like this. Oops, missed a spot. Move this out of the way. I'm gonna go ahead and separate these, and then I'm just gonna go ahead and oops, move this out of the way. I'm going to call this UCX ceiling 01, and then I'm just going to copy and paste that onto each one of these. So we got 3, 4, 5, 1, and then I can go ahead and move this back over. And if we go ahead and take all those out, I'm just going to delete history on that stuff. I don't like how these are grouped in here. we can come back out to Unreal and import all that stuff. So our ceiling, we'll go ahead and import. We won't auto-generate collision, and hopefully that worked. And then we'll also import the floor, and this didn't have a collision, so I'm just gonna let it auto-generate. And there we go. So, what I like to do when I start blocking something out is just make sure that I have something sort of like set at 0. So in this case, maybe I'll just do the wall. So I'm just gonna take the wall and just push this to 0, just so I have sort of a starting point for that. And then we can go ahead and start, dropping in these other meshes. So because this is snapping to this 10 unit grid, it's nice and easy for me to, line all this stuff up. So if I drop this pretty close to here, it's just gonna snap right on there, and we're done, right? So I can do something like, don't be afraid of doing things like, I never actually checked to see if this worked. Yep, worked. Don't be afraid to do things like negative scaling stuff, right? So on this ceiling, if we duplicate this off, it's totally fine to negative scale stuff. Sometimes people ask me like, I feel weird negative scaling stuff does something weird. It's totally okay to do that. So I can pull this over. I know there's this little center region in the middle that I'm gonna have to figure out later. I'm just gonna leave that for now. I can go ahead and pull this across and make sure it's lined up. And same with the floor. Now the floor probably is going to want to sort of be like negative scale, because there's sort of like that, if you look at the object, it sort of like comes out and then there's like a lip that comes around. But I'll just fix that later, just for blocking purposes. So once we have this, it's real easy now to just like, I can go ahead and select all this stuff. I may even want to, at this point, go ahead and start organizing things, right? If I create a folder, I can call this like, wall geo or something, right? And then I can grab all this stuff, and because everything is built on the grid, this will just snap right up nicely to here, and I can continue to build this, my channel down the road here. Right? Oops. Be careful. There we go. Right? And if we want to try out the functionality of it, as far as like, how does the player fit on here? I can take my player start and just move it out onto this platform and hit play, right? Oops, and there I am, right? And we can sort of feel like, does this feel like it's wide enough? For a regular game, if you want to have, AI and other characters to be able to move past you, maybe this should be a little bit wider. But, if it's just sort of a single player thing where you're going to wander through areas and say you want to have it feel sort of claustrophobic, maybe this is fine. But, this is where you start making those decisions. And it's okay, remember, always okay and it's better actually, to block this stuff out simply first, get into the engine, test it, and then decide that it's bad, right? Fail fast, rather than do a lot of work and like make some complex mesh and have it take forever, and then go, oh, I gotta like rebuild this whole complex thing or modify it now, and it's like this crazy mesh that already has bakes and UVs and stuff on it. Build stuff simple first, because it's gonna save your butt. So, and also like once you have this blocked out, take it and show it to your lead and be like, is this kind of like what you want? And then they can be like, no, of course not. I want those walkways to be wide enough for 2 people to walk down or something like that, right? So I digress. So before we end up here, one of the other things I want to show you, just to hammer it home, is as far as like updating those meshes, like, because I know that these walls are going to have windows in them, right? If I go in here now and I'm like, okay, I want to throw down, I'm going to throw down a center here and maybe a couple cuts in here to get my window in. I can just go ahead and like, oops, I'm gonna crash Maya. I can blow away these chunks. grab these edges. Oops. Done. Grab these edges and just close this up. And even though it's just like a simple incremental change, right? I can go ahead and I know this is already sitting right at the origin. I can go ahead and export this. And I know that because I'm saving it out into my source art meshes folder, I can save over my wall. And because I already have all this stuff laid out and set up in here, all I have to do is right click on my wall and say re-import, and everything updates all the way through my scene. So work smart. Don't do a lot of reworking, right? That's what this kind of workflow facilitates, not having to rework stuff. Because if you want to be quick and agile and react to feedback, you learn to work in a way that makes it so you can make changes quick and not have to have your lead go, oh, I want you to make those windows more narrow, and be like, that'll take me about a couple hours. Whereas you could probably be like, let me do that right now for you. What if I shrink these, export it, re-import, and be like, is this what you want? That's a lot easier than having to not knowing how to do this and then having to re-import a new mesh and replace all the meshes in there and go how does it look now? This is the way to go. Does that make sense to everybody? Yeah.
Question. You made your custom what's it called? For the roof. Did you have to separate it before or can you make the collision from one object?
I separated them. I think it actually has to be separate pieces in order for it to register as separate little cube shapes, basically. But yeah, the reason why I copied two, because I knew there were there's an odd number of segments there, so I just deleted every other one, and then I deleted every other one on the other one, and then I just separated and renamed them. Yeah.
So if you're showing organizing nicely with that, if you group all that together, can you export that group node with all those in it, or do you want to select everything in there?
I think FBX will understand outputting a group node. Just make sure when you import it into Unreal that you hit that combine meshes option. Otherwise, it'll still read every single separate mesh piece as a separate mesh piece. Does that make sense? Yeah. Yes.
So I know you did separate the roof into different shapes.
Uh-huh.
No, I was just wondering if we're more complicated mesh than that, if that's, how would you go about it?
So, hopefully you don't have to do something much more complicated than that. That's my answer. But they're actually, I don't like to show this to people right off the bat because I want people to try out the manual way, because sometimes the manual way is going to be the cleanest and most optimal way. Because you can sit there and make a bunch of cubes and spend a lot of time. One thing to show is, so let me show, here's the collision in there, right? So it's all nice and matches right up to the geo, right? But I would probably add more subdivisions into this, but this collision might be adequate for just needing to collide with that roof. But one thing that is a nice little tool in here is, so I'm just going to go ahead and blow away. So if I hit remove collision, it'll delete all that collision. If you have something that's really complicated, like a statue or something that has a lot of ins and outs and things that poke in, and there is a tool in here, and the reason why I don't show this right off the bat usually is because a lot of times it generates a lot of extraneous collision meshes, and you want that collision mesh to be as simplified as you possibly can. But if you go into collision here, there's this auto convex collision, and what this does is it looks at your geo, it voxelizes it, and then it tries to build its own version of that. So you can see this is how many holes it's going to create. So if I say let's make about 10 maximum, and I hit apply, it'll try to approximate this. So if you but you can see it makes kind of messy, dirty stuff that's not real accurate. So you can see this is a possible way to do that. I'm gonna cut this back. All right, but see, it sort of is bad. So the thing that sucks about having a computer automatically do things for you is it's never going to do it as good as you do. Probably. I mean, when it does, we can all start looking for new jobs. But you know, things that are sort of like automatic, just wrapping meshes around stuff. You know, maybe that's not the end of the world. Like the computers aren't going to take over. But this is one way to kind of approximate that. You can also crank up the precision. And then it takes a lot longer for it to do this. Blah, 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 blah. Right? So, but I feel like it's making little holes in here. So there might be ways for stuff to escape or more possibility for errors. But if you were doing something that was more organically shaped, something like this is actually pretty nice to be able to do. Yeah. Cool. So I'm going to end class here. I'm not going to continue to build this. I'm not going to make you suffer through that. I'm going to try to what I try to do every term is I try to as much as I can work through a little project with you guys. So I'm going to try to build this out as we go. The homework assignment for next week is to apply what we've learned here. So I know a lot of you guys have already started on blockouts, but what I'd like you to do is not only start your blockout in Maya, but for next week, for next Thursday, create your blockout shapes and then move them into constructing out your scene in a level in Unreal, right? So, and you should be able to do that. So if you guys have any questions, I'm going to hang out for a little bit, but class is over. And please send me emails. Come hang out with me. I won't be here this Friday, tomorrow. But I have office hours on Monday. If anybody's, because this is where it starts to get real, right? We're actually making this stuff. So if you have questions and want to meet up with me, I have time on Monday. So just let me know if you need anything. I'm always super happy to help, and there's always time for me to meet with people, or I'll try to make time. And that's one of the special things you get with having me as an instructor is you actually get to have me around while you're here. Everybody else goes off and has another job. Yo.
Do you teach all the game classes?
No.
So how many?
So I teach this class right now. I teach this class in Game Creation 2 and Demo Reel. So I'm the Demo Reel instructor for games. I used to teach texturing and shading for games, but I can't teach everything, and I don't want to actually. For those of you who are in the program, for me it's important. I could teach a lot more of the classes, but for me it's important for you guys to not only get a more varied opinion of what is cool and important for you guys to learn to get a great job, but also I don't know what my other point was, but it's good for you to just have some variety of instructors, because if you had to see me every day, it would get old, right? I know McClure teaches 11 classes or something like that, but it literally, I'm not joking, it's 11 every term he teaches about 11 or 12 classes every term. But he's a special case. He's the only person that we let do that. We actually, as the education leads, McClure's not an education lead. He's almost just a full-time instructor. He's literally the only full-time instructor. We as education leads, we're actually only allowed to teach. I think it's a maximum of 5 sections, and I think I'm maxed out now because I have two sections of this class. I have 1 section of Game Creation 2, and then Demo Reel is 2 sections. So I'm at my limit. And that's why I don't teach texturing and shading for games anymore. Even though I love that class, because that's sort of my love. I love environments, I love props, and like kind of like techie material stuff. So if there is any of that stuff, like if you guys are in texturing and shading for games and you have questions about that stuff, like that's in my wheelhouse and it's stuff that I can totally help you with. I mean, I can try to help you with a lot of different things. But for example, like Game Creation 4 deals with like scripting and blueprinting, and although I can do a certain amount of like simple caveman sort of like prototyping stuff, the guy who teaches that class, that's what he does for a job, right? So, you know, that's what we try to get for you guys is people that teach the class that is their job, their profession, right? Not just some dude that knows how to open Unreal, right? So, cool. So if there's any questions, just hang out. I'm going to save this out, and I will drop it in the folder for you guys if you want to poke at it. I will also save this. Saves as. And next week, just because I like to give a preview, we're gonna be jumping into materials. So we'll talk about getting started with materials. And I don't know if I rambled about this class or last class, but sometimes people in this class get kind of worried because they're like, well, I don't know how to do all that like baking stuff and everything. If you're like a generalist BFA or you haven't taken something like props and weapons, or you're taking it right now, for this class you're going to be safe as long as you know how to open something like Substance Painter, paint some textures on an object, and then export those textures out, and we'll walk through that workflow with like a pre-painted asset, so you can go ahead and paint stuff in Substance Painter and then bring it back into Unreal. We're not going to, unfortunately, be able to. I mean, we're going to go over some techniques for doing like tiling materials and like blending materials and stuff like that, but we're not so much going to do stuff that's like what. Like, you know, like texturing and shading for games gets a little bit into stuff like Substance Designer and things like that. So I know how to do that stuff. So if you have questions about doing those things, come hang out with me sometime. I'd be happy to like show you some stuff. But if you have texturing for games, look forward to that. That'll be something you do. Cool. All right. So here I go. I'm gonna drop this in the folder, and I'll see you guys next week.